Sidan.
Precis. Nu ska vi se. Nu kanske. Tror det lite längre upp. Så där är det bra, tror du?
Ska jag gå in och gå ut om du tar mycket? Alltså, test. Test.
Bra. Vilka presentation var det då? Pristesta. Stadsprocent i media.
Ja, så kör vi den som är högst upp sen då.
Ja. Strup tror jag också som ett enda motor. Stadsprocent i media. Jag kan testa om du vill.
Här. Nej.
Jag vet inte. Ja.
Han behöver möjlighet att du kunde vinna på ett spår.
Hello, Jan. Do you want
Oh, I
this
need a
one?
microphone.
I think.
Okay, I'll take a hand microphone. I'll give this one to Luca.
You can have one here, and also your third one as well.
Do I have to? Sorry, what did you say?
No, we have one microphone, and there was someone else who is going to speak at the same time as you who wanted the microphone.
That's Hans Bent.
Yes, exactly. So
He takes that one.
He wanted this one. So.
And I'll take this one.
Yeah, that's fine for you.
Then, of course, that's fine for me. Is it?
Leave it right now.
Can I hear myself? Can you put up on the screen?
Yeah, your presentation. This one is the right one.
That's, I think, what I want to see.
And then you also have this one to clicker.
Clicker.
Yeah.
Good. I think we're going.
Funkar det här som är bra eller? Ljudet kommer inte från nu då, men det är...
Ja, men jag kan
Good morning, everyone. How are you today? Are you having fun yet? Not yet, right? The main acts are still to come. I wanted to welcome all of you to the Digital Product Management Week. We have, I think, an incredibly exciting program ahead for you, and we're going to soon start with the highlight of the day, which is the keynote by Luca. But what I wanted to do is two things. One, give a quick introduction of why are we organizing this day, or these 2 days, or this week, the Digital Product Management Week. And then after that, and then talk you briefly through the program. And then Hans Bent will say a few words as the chair of the board of the International Software Product Management Association, because this summit is part of the Digital Product Management Week. And then we kick things off. Why are we organizing this week? I have been a professor of software engineering for almost 30 years. I know I don't look that old, but I am that old. And for almost all of my career, I have focused on how do we build software-intensive systems? How do we build the architectures? How do we build the agile teams? How do we build the test infrastructure and all this other good stuff? And then together with my colleague, Helena, who's sitting here in the front, we started to look into, but all this stuff that we built, is it actually used? And things became pretty quickly, pretty obvious that something quite terrible is going on. Our research shows, as well as research by others, that somewhere between half and 2/3 of all the new features in typical systems are never used or used so seldomly that they shouldn't have been built in the first place. Not only that, if we divide the functionality in systems into commodity functionality, differentiating functionality, and innovative or experimental functionality, the typical data that we have is that somewhere between 70 and 90% of all R&D resources are spent on commodity functionality. Stuff that no customer gives a flying hoot about. It should just work. So we're in a situation that 7 to 9 out of every 10 people are working on stuff that no customer gives a flying hoot about. And the 1 or 2 that build new stuff all the time get it wrong half the time. I have the feeling that this is a product management challenge that we have to do something about. And that was when we started to talk about we should do something in the space of product management to actually start to address this challenge. And why now? And why Digital Product Management Week? Because I'm pretty sure that all of you have heard the word AI more often than what you can think of. And we have a opening keynote that's actually diving into that thing. AI is fundamentally changing the way that we do product management, I believe. Yeah, the use of data, every company is drowning in data, but is doing very, very little with that data. And we have some beautiful cases, if you're interested in that I can talk you through. Yeah, so we're really looking for ways in which we can fundamentally change the way that we do product management in order to increase the effectiveness of R&D efforts such that the people that build software actually generate real value for the companies that they work for. That's the story behind the Digital Product Management Week. Yeah, that's why we're in this room together, to address this challenge. We have a very exciting program for you, at least I think so. We're going to start with someone who I think is the smartest, most visionary, and most intelligent person that I've worked with, Luca Cimkovic-Fries. I know that I still do not get the name pronunciation right. After that, we have a session, one presentation on responsible AI principles. And then Hendrik, also sitting here in the front, will give a presentation. Then we have a coffee break. And then we have 2 more presentations before lunch. Product manager versus product owner and the relation between product manager and other roles. Then after lunch, and by the way, that's maybe good for those of you that have been to summits before. These used to be paid for events that were in the 700 or 800 euro range, I think. This event is free. Yeah, you must have noticed that you didn't pay anything. But that means that you have to pay for your own lunch, your own travel, your own everything. So lunch is on your own. Yeah? Sorry, guys. I didn't get any sponsorship for this thing, and the whole thing is costing like the dickens. So I can't feed you too. Yeah? Sorry about that. Yeah? But in any case, you're on your lunch. Then Xiaofeng will chair a session right after lunch. There's a coffee break. And then there is a panel discussion by little me. And the topic of the panel discussion is time to let go of Agile. What is next? I have declared Agile dead, which Xiaofeng thinks is really, really funny and a little upsetting. She just ran the XP conference in Bolzano, so I'm pretty sure it's and then tonight there's a conference dinner. But guess what? The conference dinner is also on your own dime. How cool is that? Okay. But we have a super nice place right across the street. We want to encourage all of you to get there as quickly as possible. And then we continue tomorrow with a few sessions. I'm not going to talk about that now because that will become clear. I will present that tomorrow morning. But what is perhaps good to know is that at 5 o'clock today, there is the ISP May membership assembly. So all of you that are ISP May fellows, please come to that membership assembly. It is in Kuken, which is the red round building in room 342. And I actually hope that people can get in there. But we'll work that out. Yeah, and with that, before I introduce the keynote speaker, I would like to invite Hans Bent to come on stage and say a few words on behalf of the board of ISPMA.
Thank you, Jan.
You need this? Yeah. Can you switch slides and bring up Hans Bent?
Good morning, everybody. welcome to the SPM Summit Europe. We are very happy that we can have this SPM Summit, which is number 7, I think, in Europe, here as part of the Digital Product Management Week. If you are not familiar with ISPMA, ISPMA is the International Software Product Management Association. We are a non-profit organization that is dedicated to establishing SPM as a discipline of its own, both in academia and the industries. And what you see here, these are our so-called fellows. Quite a few of them are here this week. And these are the people who are responsible for the content of what we call the body of knowledge on software product management. As you can see, this is a pretty international, pretty diverse group of people, and we are very proud of this because we are the only organization in the product management education space that has such a knowledge background. What is new in ISPMA? Well, we continue our international expansion. We already have footholds all over Europe and in India, and now we are going into North America. Last September, we had our first SPM Summit in Berkeley at the University of California. And so that is a very nice development. A new book was published last year on software product management for startups. This is not only about startups, but also about new product development in established organizations. We started to establish what we call university chapters. So we already have actually 2 now in India, 1 in Berkeley in the US, and I'm happy to announce that we have the first university chapter now in Europe at LUT in Finland, thanks to Andre and Sami, 2 of our fellows here. So the idea behind these university chapters is that we want to get in touch with students that study software product management or related things and are interested in this. And this has started quite nicely. And actually, the students in Berkeley are going to organize the next SPM Summit in that location. Yesterday, at the welcome reception, I got a number of questions. What is a digital product? And we actually had quite some discussions on this before this conference. There is no generally agreed upon definition of this term. And I hope we can use this week to have a discussion on this. Let's start the discussion with a proposal that I have come up with. This is not an ISPMA definition. So I would define a digital product as a product characterized by computerized technology. And in that sense, it's a synonym to software-intensive product. This includes pure software products, physical products with embedded software, artificial intelligence products, and data products with dynamically changing data. It does not include products that deliver static content in a digital format, like ebooks or music files, that kind of thing. These products are typically delivered to customers in multiple formats. The book is delivered as a hardcover, softcover, paperback, and ebook. But the product is the book. So the fact that digital is a way of delivering it is not really characteristic of the product. So that's why I defined it this way, but I'm happy to have a discussion on this. With that, I would like to give a big thank you to Jan as the chairman and Helena as the chair of the program committee. Please give a big hand to the two of them. And also to the whole team that is supporting this Digital Product Management Week. So a big thank you to everybody, and I wish you a most interesting and most productive week.
Thank you.
Thank you. Wonderful. Thank you very much, Anton. I don't have slides right now. I will leave this and look at if you put these on, then you can talk. It may not be muted. I'm not even sure if it's on, but you can figure that out. Can you bring up Luca's slides? Oh, it's on the computer. Okay, that's good. Luca and I got to know each other via his father, actually, who's no longer with us. But at that point, we started to have a discussion around potentially doing some research activities together. And this is quite a few months ago. Then he got the opportunity by a significant round of funding from EQT to start a company on a deep learning platform. The company was called Peltarion. And he invited me to join the board of that company. And I must admit that over the years, the company was bought by King 2 years ago, actually, exactly yesterday, 2 years ago. I was on the board and I got to experience Luca for 4 or 5 years, I think, maybe even 6 years in Peltarion, being a board member. And I just think this guy walks on water. And I don't say that of many people, but I've never met someone who is so visionary, who has such a deep understanding of technology, who is such a wonderful human being towards his staff and employees and the people around him, and who generally has a very good understanding of where the world is going, especially when it comes to AI. He's currently head of AI at King. I think that everyone knows that King was bought by Microsoft about a year ago, I think, if I'm not mistaken. Of course, within the Microsoft context, the main AI spot is kept by OpenAI. And Luca just happens to have lunch with Sam Altman on a regular basis. Is that a fair way of putting it? Not quite. But I mean, they work, at least they're in the same organization, and I think quite well connected. So I have been very much looking forward to his keynote this morning, where he will talk about how King works with artificial intelligence and what he sees as the future for this, both for product management, but also for general product development. So with that, please join me in welcoming Luca on the stage. Thank you very much, Luca.
Thanks, Jan. That was way to come. Oh, let's fix this. So when Jan asked me to come here, of course I had to say yes. It was always really a pleasure working with Jan, and yeah, I really enjoyed this opportunity to get to talk to him and catch up. But also talking a bit about product management, and I should make something very clear. I'm not a product manager, so I did have a little bit of feeling like I feel a bit of a phony discussing product management, especially since I stole lots of slides here from one of our best product managers there in my organization, Patrick. But hopefully I can contribute something of the AI perspective. Just so you know, if I get some basic product management stuff wrong, it's because I'm not a product manager. So, King. Candy Crush is King. Everybody knows about Candy Crush. 200 million, 250 million monthly active players. It was released in 2014, so it had a 10-year celebration now. King is a Swedish company, was originally based out of Stockholm, but now we're in London, Barcelona, Berlin, Malmö, and San Francisco. Part of Microsoft since last year. And the area that we're in, it's casual mobile gaming. So it's games that you play to relax a bit, essentially. They're not very demanding. They're just small bits of entertainment to de-stress. And another important bit is that they are free to play, which impacts the commercial model, how it works. And the commercial model, of course, then implements how you design the product. So essentially, the vast majority of our players, 90%, have not paid anything. So it's based on, the economy is based around in-app purchases, when people want to buy a booster to get quicker along the game or items in that. Now, data at King. So King was built, and Candy Crush in particular was built from a data foundation from day one. And the process is centered around, so the software development process is very much centered around A/B tests. And it works like we're running hundreds of them in parallel at any given moment. There's a massive amount of data. So peak throughput that we get is about 3 billion events per minute that come from the players. And the process of how it works is you get the data, and from that you perform analytics, and there you get some idea of, the players seem to like this, or we see these patterns. And then you make what we call product interventions and optimizations, P&Os, lovingly, which is essentially adding a product feature or improving it. And that's, so you use the analysis from the data to form the hypothesis for what the next feature should be, what the next improvement should be. Then you do that improvement, and you A/B test it, and then you collect the data and repeat the process. And there's nothing revolutionary about this approach. This is like a very typical thing that you're expected to do. But what I think differentiates King is the scale of things. And the other bit is that this has been perfected over a decade. So the tools are quite sophisticated, the processes are quite repeatable, and there's a system in place that works really well. But looking at A/B testing, there are some fantastic advantages. I mean, we have a proven track record, 10 years of growth, that has just really worked for us. Product decisions are made based on data. There's a mature and efficient process around it. And it's also very parallelizable. You can have multiple teams working on different aspects of the data and just running things in parallel. It's also very easy to track. When you do the A/B test, you track the financial metrics. You can add things up, and you know what, in theory, what the impact will be. But there are limits to this system. I think King is in a relatively interesting position, as we've been doing this for a long time. That, you get advantages over the previous way of building things, but there are new disadvantages that come up. First, it's super hard to see what is correlation and what is cause and effect, especially when you're running hundreds of these at a time. So what caused something? You don't know really. And we have processes of trying to decorrelate A/B tests. That works so. So it's hard to get an understanding of why something works and why something doesn't. Data-driven product decisions are problematic because there's a limited number of people who actually do it properly and know how to interpret an A/B test and to make solid decisions. We make tons of decisions on A/B tests all the time. I would not say all of them are solid decisions. Especially since we're just doing everywhere in the organization. Personalization is difficult. Also, I think, okay, you have 200 million players in Candy, so this should be, you can test on so many people. Yeah, yes and no. In one way, you don't run an A/B test across all of the population because, like, you don't want to break the game and the revenue stream. The second bit is when it's try to control for a number of variables and try to say, okay, geography, time of day, demographics, and so on. That groups, even when you start off with something as big as 200 million, you very quickly come down to a relatively small set, and means that you have to run the test for a while. So then a few weeks sort of to get good results. It's detrimental to product cohesion. When you have people in parallel teams that are just working off of data, building these assumptions and so on, and doing it independently, not really, of course, everybody has a hypothesis of why something is, but not really understanding why the players want this and that. It's sort of not destroyed, but it compromises the product as a whole, where you have this central idea of what this should be. And it's also very hard to track the actual impact over long periods of time. You do this A/B test, you see, okay, there was a gross bookings uplift, or retention improved this much. And it's great, we put it into production. But since we're running so many, there's no way of following up. And especially since you're adding test after test and modification after modification, what you did initially, it's not valid anymore after you've deployed a number of other features that interfere with this. So you actually have no great idea of how this will play out in the long term, and you have no way of looking back and saying, like, oh, this was a great decision. Let's try to do more of this again. And it's hard to also to account for reversion to the mean that inevitably happens in all these things. So where we are today is that we're going through a major shift where we're going from A/B testing to essentially AI-based player models. Rather than going out and testing things with players, we have a model, a machine learning model, that can behave like the player, or that understands the player. So essentially it's simulating the player, the machine learning model. We're moving from this feature-centered thing to a more player-centric, so more focus on personalization and delivering personalized content. And this is from a product management perspective and an organizational perspective, that you don't group things around particular features, but you sort of go through this player experience. And the other thing is, there's always this, like in Candy, you can play the games, of course, the levels. But that's just only one type of content that's being served. We also have videos, we also have other mini games, we have different types of, there's music. There was a big pop star launching their album on Candy Crush last year. So there are a bunch of different types of content. And where we are moving to now is that we see features, game features, like how the game behaves, or an additional aspect as content, that it can be deployed in the same way that we would deploy a level or something like that. So that content becomes this fairly broad and I would say agnostic, but it doesn't matter if it's code, if it's a level, if it's a video, and so on. And that the software itself is more of a serving platform for that content. And the reason for that decision is that it can be personalized in a very different way when you have that approach, rather than where you have to make massive code changes each time you want to make a change to how the game works. Which brings us to AI. So machine learning and AI have been part of King for quite a while. So the first AI team was founded in 2016. It was a research team of about 10 people. And they started with building bots for playing levels, essentially to help the level designers to make better levels. So they could test the level and you could see how hard it was and what quality it was and so on. But there's always this very fine balance with levels. If it's too hard, people give up and don't play. If it's too easy, people get bored and don't play. So you always have to sort of, there's a very narrow range where people like to play. Ish people on the AI side. King is 2,000 people and we have 100 people. So in the game, at least in the game world, there's quite a significant chunk. So it's a serious investment. And we started off with doing use cases for the games, and then that moved also now with what happened with LLMs, in particular after GPT-4 was released, not to just look at in the games, but also what could it do to improve our productivity. So that's another major branch. And essentially, game automation, that's a big thing that we're doing. Improving our production, how we make the games, our work, that's another thing. And then transformation, which is essentially this move from being data first to AI first. Now at King, almost every cross-functional team has a data engineer in it. And that's part of the data first bit. So that's in place. What we're working now is that rather than having my central organization doing everything AI, is actually that these cross-functional teams should have that capabilities, those capabilities and knowledge on their own. And that's in part organizational transformation, part enablement. We're holding the King AI Academy, where we hold courses and upskilling and so on. And that's another big part. Then we have a research team, AI Labs, and an enablement team that does these courses and so on. Now, looking at AI in the games, and this is a bit sort of when people think a game like Candy Crush, you're thinking about the product, like the app. But the fact is, the majority of things is running the system. So King is more of a game operations company than it is a game production company. But of course, you have to build the products for that, or operation to work. Candy, for instance, think of it as a three-tiered experience. So you have, first you have the sort of just the game. You swipe candies. Then there's the saga progression app where things happen. You sort of have a progression when it happens. And then there's like sort of these events, like competitions. It could be videos, it could be the various forms of challenges and mini games and so on. Things that sort of happen on the side. And in the background, it's a fairly complex process where you have the interplay of the software, you have the performance marketing, you have the in-app purchases, the store. We also display ads that players can choose to watch if they want, for in exchange for getting a booster or something like that. And balancing that to the sort of core variables such as retention and gross bookings and things like that. And in this process, there are always a number of decisions across the path to be made. And simplified, it could look like the player plays a level, and then finishes the level, succeeds or fails, whatever. And then comes a decision point, like, what do we do now? We just go to the next level, or do we suggest a minigame, or have they just lost the level and we suggest, oh, if you buy this booster, you can get it faster, something like that. So there are a number of different types of things that you can do after the sort of play level. And you can imagine this, that this is you want to find for the individual player an optimal policy of what to do based on their actions. What's the best next action to do for the player? And this policy is learned over time. So what we're talking about here in terms of machine learning, it's reinforcement learning based things. of the machine learning persuasion. So that the goal is that for each individual we get this optimal progression. And it's not the same thing as hyper-personalization, which is also a possible path in the future, which is where the game content adjusts and it's created in real time just for the player. But this is more of a curated experience. So you have a number of different options that have been curated by human product managers and artists and so on. And then the AI system, let's say, essentially selects the sequence of things dynamically based on where the player is. Now, at the core of this is understanding the player. They're talking about switching out A/B testing for AI models on the players. And the basic part there is player embeddings. Right? So we have actually, our AI Labs has published a number of papers on this particular topic. The research has been ongoing for a while. You can think of it, if you think of LLM, like GPT-4, you get the first step is when you have this sequence of words, is transforming that into a vector of numbers. So it's a numeric representation of that bit. This is the equivalent, but instead of words, you have the sequence of player events. So essentially what a player did, the number of steps for a period of time. And this gives you a core representation of what this player is about, what the style of playing, what do they like, how much they spent in the game and things like that. The other bit is decision automation engines. These are essentially reinforcement learning based systems that, based on the player embeddings, pick the best content. And the final component is the content pool, which is the sort of selectable space of what can be done. As I said, content is a broad term. It could be an in-game feature, it could be a level, it could be pretty much anything. And features of the content is essentially about it changes quite a bit the approach when you have product management, when you start thinking about that. Because again, you have this tension of trying to create a coherent experience while at the same time creating a personalized experience. So it's a different type of product management challenge where you sort of, rather than defining specifically the player journey, you are mapping out the space of player journeys and the sort of possibilities of, and you set boundaries, like, we don't want to go there, like this is off limits, this goes against the sort of values that we have and so on, rather than in detail specifying things. Which brings me to product management. First, just want a bit of a nomenclature thing, machine learning and AI. So here when I'm going to say AI, I'm going to talk about generative AI. That's the sort of LLMs. Well, machine learning is more deep learning and those things connected to it. And today they are quite, sort of the applications are quite different. The way you use them is quite different. So machine learning, it solves narrow problems in one domain, like classifying, like will this play a chart? It's significantly better than human capability, otherwise you wouldn't use it. So the sort of basic requirement is that it has to be a lot better than a human. And it needs a lot of data. It can handle a lot of data, which is the great thing. But it also needs a lot of data for training. It requires high level of expertise in terms of team. It uses complex software platforms and so on. Upside is it's your custom thing, so you have, it's a black box still, but it's your black box. It's super expensive to set up, but once you have it, it's cheap to run. And I would argue that from the Peltarian experience and so on, sort of, but the machine learning part is what most industry and enterprises struggle with, because there's so much needed. You need to have that structured data in place. You need to have be able to hire the right people. You need to set up this very complex software stack and so on. At King, this was relatively simple because the data was in place. So when we started doing use cases there at scale, everything was already served up. So it was less of a challenge. But this is, the bar of entry here is quite high for most things. And the result of this, you get better product. So that's in our case, better games. Then we have AI, generative AI. It solves generic problems across lots of domains. It's sort of, kind of comparable to human intelligence, at least in some bits. Good news, you don't need any data, at least if you're using the sort of pre-trained ones. If you're going into like building your own foundational models and that, then you're in this section plus a whole world of hurt. So yeah.
Don't go there.
Don't go there. But for most, it's super simple. You have a very simple, just API call away, and you have this intelligence call, just natural language. Or especially for product management, tasks, like just use ChatGPT. You don't even have to use an API. It's limited, so like 128K tokens for GPT-4. There's some Google models that are 10 million tokens, but in reality, these are not 10 million tokens. There are 128 tokens that have been diluted. It's not exactly the same thing. But the point here is that it's a limited amount of data. Like I remember we were the largest single code file in Candy Crush that defines the playing board did not fit in the context memory of GPT-4. Like that was just one file. So it's very limited, and it's the equivalent. That was, I think, the 32K model. This is the 128K is like 500 pages of text, roughly, which you say it's a lot. But if you're comparing it to what a human can keep in active memory and so on. But it's not when you compare to the like billions and billions of data points that a machine learning system can typically just push through and train on and so on. It's somebody else's black box that you don't control, unless you're Microsoft, and then you do. And they're cheap to set up, but can be expensive to run. And there's a qualify that statement. If you're using it for internal stuff, like getting up for internal tools, then it's cheap. Then it's like ridiculously cheap. If you have 200 something million monthly users, and you want each user to have an agent of their own, then it becomes expensive. Now, those are the definitions. So let's start with machine learning. So machine learning, as I said, it's complex, but it doesn't end there because the machine learning is just a small part of the whole process of getting a machine-powered product in place. Apart from the MLOps and DevOps and so on, you also need a product development process that is suited for machine learning. And it's quite different from traditional software engineering. With traditional software engineering, you sort of have an idea of, if I spend this much time, I'll get this type of output, kind of thing. With machine learning, you have absolutely no idea if it will work or not when you start off. Essentially, you only get proof of value after you've essentially solved the problem on the machine learning side. So it's a very risky, it's a very uncertain thing when you start off, when you say like, oh, I have this hypothesis, I think this will work. You have actually no idea if it will work or not until you try it. And when it doesn't work, you can say, okay, perhaps I'll add some other data to it and see if that solves it and so on. But there's no systematic way, there's no deductive way of saying, this doesn't work because this and this and this. But so experiment, iterate, and you still know how well the output will be. And of course, it's just one building block within the sort of whole product cycle, building a product cycle. And this little black box, you see that's the sort of ML code, that's building the model. That's typically the smallest part of it all. It's a highly iterative process. You sort of explore with different models, you try with different data, you deploy it, then you go back and change it and so on. So it's a cycle that doesn't end. And especially if you're dependent on external data sources, this is also now you have some dynamic functionality in your product. That's how much control do you have over it. There was a Google paper, it's a bunch of years ago. They called machine learning the high interest credit card of software engineering. It's an apt analogy because you're building in a lot of uncontrollable technical debt essentially in it that you don't know. Your system is dynamic and you have these external dependencies, and then suddenly your product starts behaving differently and you don't know why. And it was because some machine learning model somewhere is getting some other data and so on. And it's also very tempting, like you build this nice machine learning model something, and then to make it user friendly, you slap on an API interface to it, and then people are like, oh look, here's this fancy API that I can use that gives me exactly what I want. And then I start using it and not realizing that this is something that's changing or don't know how it's been built and so on. So it introduces certain complexity. But at King, the way the machine learning lifecycle looks like is that we have tools where data scientists can discover data, play with it, and together with product managers evaluate new opportunities and so on. This can be debated, like having both is good. Being data driven is good. It's good to like not just inventing shit and hoping that it works out, but sort of having some grounding in reality is good. But at the same time, too much relying on just data erodes any type of like, what's the product vision? What is this thing? And especially if you're doing it in parallel in many places, you can sort of pull into different directions. So there's an interesting tension there between product management in terms of having a vision for what this product should be and what this other stakeholders want, and then what you're getting from the data, the signals of what you think the data says that the users want. So there's a big first interesting discussion there. Now what we have is a bunch of different project templates for different type of machine learning projects that data scientists can use to get started quickly. They start building their models and then they test them offline, essentially just in their own environment, building a model, trying out with historical data or synthetic data to get an indication like this works or it doesn't. Then comes the pipelining part where we work with data engineers to connect it to the system. And here King has a lot of tools for doing that pretty much automatically, and there's lots of experience there. Then the model is deployed, then you A/B test it, somebody's actually monitoring and takes action, and there's a process of taking action. In practice, what we've seen at King at least is that it's less of a problem. So in Plutarium, our hypothesis was that when companies are starting to build lots of these models, it's going to be a mess. So you need something to manage it, you need something to control it and so on. What we've seen at King is that yes, in theory, but in practice, these 100 models are not really 100 models, but there are perhaps 20 generations of 5 models to sort of develop. When you find something great, you don't go and do something completely different, but you build on top of that. And because there's a fairly narrow spread there, you still can track that. And especially if you have it connected to financial systems, then you have finance coming in there being very upset if something's off. So there is a built-in system there. Now, if we're moving to more automated decision making, how does that change things? Well, mostly on this part. So rather than having just deploying the model and A/B testing it, is that it's deployed to this content pool, and then the automated decision engine essentially chooses if it wants to use it or not. The rest of the process is fairly similar. So from a process point of view of how program managers and data scientists work together, it's fairly similar. But there are more radical versions of this, and that's I'm going to talk in the future segment. Now, when it comes to product management for machine learning, the fundamentals are the same. I mean, it's the intersection of what the user needs, what the business needs, and the technology. So it's the sort of same fundamental things. Product managers need to understand machine learning, and this is not an easy skill set to find, like product managers with machine learning knowledge. But the primary role that we've noticed is sort of the greatest good that gives is bridging the gap between the understanding of the product and understanding of the machine learning bits. And that sort of needs to fall into place for it to click. Now, on the AI side, this again talking generative AI and more on the game production side. First is that we're going through a platform shift right now. It's changing already radically of how any software is being created, and also on the operations side how it's being operated. And we're entering an era where the cost of any type of content production, be it code, be it image, be it a video, and so on, that's rapidly going to zero. And there's also new user interface pattern that I don't think we figure out yet how to use well. Perhaps with the new voice to multimodal voice native models will make it more natural. But the text typing natural language is great for some things. It's terrible interface for others. But we have this new interface. How's that going to change things? And from King perspective, King's in the past, sort of the great moments were in platform shift. So when Facebook grew, that was the sort of first exponential growth King. Facebook provided the social graph. You could see everybody's friends and you can invite them. This was before GDPR and anybody knew what privacy meant. It was fantastic days. You could get like all of the data for companies. The second was on when mobile came. Bing was one of the first to be on mobile. So this is a platform shift. So of course we are looking into this very, very much also. What does this mean for us? As we know, platform shifts typically make or break companies. Now the production part, it's relatively easy to understand. How you can increase productivity is fairly straightforward. On the product side, it's harder. I literally can't see exactly how this will impact King's product or any other products for that way. There are some that are more obvious than others. Ours is, I think, not. We have a very, like a 2D visual match-3 type of a game. How would the conversational interface improve on that? But it's, there's going to be an impact. But the easy part, it's essentially workflow automation, going from manually labor-intensive production process to automated workflows. So you reduce any type of bottlenecks and inefficiencies that you have to remove administrative tasks by having AI tools and systems. And this allows more time to focus on innovation and building good products. Spending less time on the overhead. That's the sort of big promise of workflow automation. As for product management, I think we're in for a radical change. I think the admin routine tasks will become much less of part of the job. So less time spending writing user stories, requirements, and so on. think there will be an impact on the product life cycle, that you'll be able to do higher frequency, faster updates, quicker iterations. But I think that the need for good product management, that will only increase. This doesn't replace the need for product management. On the contrary, it creates great demands on it, and it's a more dynamic type of environment. And you remove or automate a lot of the things that can come in the way of being a good product manager. Like writing a lot of text. Product managers write a lot of text, in my experience. And obviously these systems help out with that. Getting that faster, being able to focus on the core ideas, clarifying that, the good thing. And for product managers, there's a strategic advantage in terms of quickly spotting trends. You can analyze data, you can improve your decision making. More efficiency, as I said, administrative tasks, communication, going through faster product cycles, just stakeholder management, where you have like 5 different stakeholders that are pulling to different directions, getting a coherent story out of that. For that, it's super helpful. And improving accuracy and understanding of the users. So really for parsing user data. We'll show a practical example of what we did at King, a case study of CAKE. CAKE stands for Cognitive Assistance, King Enablement, Cognitive Assistance, King Enablement. That was it. It was GPT generated acronym.
Because it makes it so easy to remember.
Yeah, I love the name. It's very sort of King sweets and so on. Essentially, this was before there was a ChatGPT Enterprise, where this is when the GPT-4 API was released. We built our own internal chat client, essentially, called Kingversation, and also plugins for Visual Studio and for JetBrains. And we ran it as a pilot program. We had about 300 people doing it. Being part of the pilot, half were tech people, half were not, in different crafts and areas and teams. So we got a good representation of all King. And running it on our own, we got a good chance of trying things out. And everything was logged, and everybody was fine with that. That was part of the participation thing. So we could do analysis on what people were doing, what they were using it for, what kind of things they encountered and so on. So we logged our data, we had analytics on it, and what we tried to extract was like themes of what are people using it for. There was also a big ask from the legal team, what are people using it for? Different tone of voice. And also a specific focus on creating code. A lot of survey-based stuff, daily check-ins for users, and then fortnightly this sort of systematic type of surveys. And we did also some other experiments, like we ran a code competition at the end, trying to see how much of improvement do we see when people were using the tool versus not. And we also rolled it out King-wide and measured all it and see how the adoption curves looked and so on. Now, in terms of conversation data, so you get a lot of long text format stuff there, massive types of long. So we have the basis of some 6,000 conversations, and we want to understand, is this useful? Is it impactful? And we wanted to know, when we talk to people, do we talk to them by craft? So is it data scientists, regardless of which department, or is it per team? Or what kind of grouping is relevant here? And what we could see from data, that there was was a very weak correlation between different themes what people were using it for, and the themes they were in. But there was a very strong correlation between what craft they were in. So artists were using it for one thing, software developers were using it for another thing, product managers were using it for a third thing, and so on. And we aligned this with the sort of survey result and interview results that we got. And from that, we could actually say, okay, when we are deploying this king-wide, we should take this craft-based first approach. These are the themes relevant for this craft. Let's find use cases for this, and so on. Another example was working with the legal department. There's a massive knowledge gap between what the legal team knows about how AI works or software development works or any of that stuff. And since it's been a lot in the media about copyright issues, IP issues, or surrounding generative AI, they were very hesitant of just about allowing anything. And what they were very interested in was like, what's the risk profile? If we release, like everybody can use this at King, what will they be doing? What are their risks? And essentially, what we used there was use GPT-4 for it. We gave it the legal guidelines and asked it to categorize things into like no risk, low risk, medium risk, high risk, and blatant infringement. And then we did follow up with manual checks, which we checked all of the blatant infringement and high risk stuff. And it actually turned out this was the security department doing penetration testing and things like that, which were legit part of their work, but could be seen as dodgy. And so this type of thing, we could show this to the legal department, it really opened things up that they understood that, okay, this is not a high risk, there is a way of verifying that we're staying within limits and so on. And this is also a question of like, okay, how can we balance this with we don't, essentially, we want to treat the conversations that people have with their chatbots roughly like we treat emails. Like it's not something that the employer should look at. They should be accessible in case there is a legal thing or something like that, but it should not be something that's routinely available. Now this opens up the opportunity of having it on the app side. So just the user gets are you sure you want to continue doing this? This seems to be violating things, but doesn't go to the legal department. Right? So there is oversight, but not human oversight. That was the theory. Right? Then we went with ChatGPT Enterprise when it was released and didn't go pursue this path, so it became irrelevant. But it was an interesting thought idea of how do you make sure that the legal stuff is followed without creating this mass surveillance type of thing that we don't want. Interesting bit from the survey data was also that we saw, and so the first answers when they started using it, and then the last answers when the pilot was done. And the first question is, I would find conversation useful in my job, and the other one was using conversation enables me to accomplish tasks more quickly. And we can see that using the tool leads to so people get it, why that is useful. Then also, this was sort of the end of the pilot was that we held a King-wide coding competition where there were a number of programming tasks, and we divided the participants into 3 groups. One were on their own and doing it manually. Another group had access to Conversation, but had not received any prior training. And the third group had access to Conversation, and were part of the original pilot group. So they had previous experience. And we start off at this one. So the orange one is the book one, is the human only. And this is time how long time it took to solve the task. So lower is better. Blue is the ones that have gone through the Click pilot program, and the green one are that use AI but have not had any prior training. And what we could see a 36% productivity impact in the context of specific tasks that are a very narrow context. But it also showed that it did help. It helped a lot, most people who were inexperienced in writing software. But it also, when the context is narrow, then it helps really the inexperienced users. When the context is broad, then it really helps the more experienced users. So those are the ones. While open problem, inexperienced user plus AI doesn't work, and narrow problem, experienced user plus AI also doesn't give much result. So that's the thing. We saw that enablement was important. Experience using the tools were important. And particularly if we look at the PM craft, the most impactful change was being able to take any text type of user feedback and type of entering that into actionable data. And now the bit that Jan has been waiting for. So what about the future? So I'm going to use two sources here, and these are based on public statements. So I'm not saying anything confidential here. So from Sam Altman, so if we compare the generations of GPT-3 to GPT-Next or GPT-5, whatever it will be called, well, the GPT-3 was capable of doing 5-second tasks, like things that would take a human 5 seconds to do. GPT-4 was capable of doing 5-minute tasks, while GPT-Next will do, which will be released this year, 5-hour tasks. With GPT-3, we have this coherent text generation that was pretty revolutionary. With GPT-4, we got the alignment, so it not just could produce text, it could be meaningful text that sounded well and resonates well with human. But still have this hallucination problem somewhat. With GPT-5, we'll see vastly improved reliability of the system. With 3, we got some basic reasoning. I think the first coding assistants came around this time. It got a lot better with GPT-4, and we can expect a lot better with GPT-5. Another on GPT-5 is that there's been a big focus of agentic using agents, more autonomy, rather than this just ping pong back and forth in a conversation. More that it can act independently and in doing multiple tasks, and also focus on personalization. Another thing is Kevin Scott, that's the Microsoft CTO. It was a Microsoft Build conference a couple of weeks ago, and he was talking about the sort of exponential improvements of the models and the size of the models. And he was talking about specifically model size, and he made a fish comparison for some reason. So it was like GPT-3 was like a shark, 600 kilograms. And there's Orca, that's GPT-4, that's 3,600, and the new one, Blue Whale, 150,000 kilograms. But I have no idea if these numbers are correct, they're GPT. But it sounds reasonable. But it's really the compute being used. And I was talking about the perspective of the compute, the server side and so on. Is that it's gone from $1 million computers to $1 billion computers, and now they're talking about $1 trillion computers. So there's this massive investment in compute that's growing exponentially, and what we've seen so far is that these models scale really well. We see no end in sight in terms of compute, so how well it scales. This is stolen from Sam Altman when I was talking about startups. That right now, but this goes, I think, for just about any company, is that you sort of have this sphere of capability that GPT-4 provides, and that most startups and most companies are sort of putting right there, like extend it a little bit, which is not as really sustainable to do, because then comes GPT-5, and it's just gonna blow away all of this area here. So the most important thing is to think ahead. And this, of course, isn't easy because you don't really know exactly what ahead is and how to quantify it, but think further is a key message. Think not what can be a little bit beyond what can be done today, but think what can be. Well, we know GPT-5 is going to be loads better than GPT-4, and GPT-6 is going to be loads better than GPT-5. So stretch it out. And the big point is these are not with the models. Is that these are. It's not just text generating, poem generating stuff. These are scalable reasoning engines. And that has profound implications. And you'll see a lot of the next 6 months. The big buzzer is going to be agentic, of essentially using these as multiple levels of agents interacting. We're not there today yet with GPT-4. It's too inaccurate to be used in any type of depth. If you have 5 level of agents and each has a 90% chance of producing an accurate result, if you're building one on the other, then it's you're down to 59% probability of getting an accurate result at the end. But going wide can work. So Phi 2, Microsoft developed a small language model that can run on mobile. And I'm going to speed things up here as I'm running out of time. But I'm going to show you a model of how this might work in the game perspective. Now, today, you have the game client mobile phone. There's a selection process of data where we think we're going to use this, and this. And these are chosen on basis of what we think is useful and that it doesn't violate the privacy. Then it goes to an anonymization layer. From that, there's features that go into the AI model that's built, and then goes some action back. The problem is that you're trying to guess here, after a big filtering process and a lot of assumption, what the player needs and wants. Instead, you can imagine having one device, a player AI, so one agent for each player that gets to know the player. That AI communicates with a central AI and says, look, here, Bob likes this, and this, has this type of preferences and so on. And then the central says, okay, great, I'll talk to the level AI, to the game AI, to the UX AI, and we'll get some kind of great thing just for Bob. And then sort of sends it over there. And the point is being that at this point, you can get a much deeper understanding of the player without having to invade player privacy. So that all of this can stay on device, and only the relevant things get sent over to the central side. Because this AI knows both what the game is about and knows the player. So that's the possibility of distributed intelligence. It's very interesting. And I'll forget about this, but changes are AI, more AI, 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 AI. Yeah, lots of AI. Final thoughts, 30 seconds. 3 different paths that I talk about here. So the ML-powered optimization, sort of enhancing specific features with machine learning. The second one is when you start moving into more having a optimized policy with AI. Both of these represent kind of different types of product management challenges. And then we have sort of this kind of distributed reasoning engines type of things, which is more speculative, but far more transformative. And no idea how that will impact product management. I think we'll see when we get there, but there will be impact. What we can do now is on the product management side, it's for just this practical everyday work, like getting actionable insights from lots of text data. Obvious use case, but it's just so useful. It really takes the product management process to a different level. And generally the process of managing stakeholders. For me, and not just in product management area, just multiple views generating, combining it. Yeah, my parting thing here would be that think about the broader implications in the long term, where this is going, how much this is developing, how fast, and what this means for product management. Nobody's, I mean, people are thinking, but there are no solutions. There's a lot of space for innovation and great ideas.
Wonderful. We're going to use 1 or 2 minutes for questions, but I'm going to swap the coffee break in the next presentation session. So we're first going to have coffee after we're done with this, and then we're going to continue. Sorry, you single-handedly overruled the program share.
I don't mind.
So is there any questions to this fine specimen of the human species? Yes, Mika, we're going to get a microphone because we're streaming live, in case you wondered.
So I just had a question about your player model. Is it a single avatar for all of the players, or do you have, how do you sort of, is there any sort of personalization in your player model?
So the player model is just going from this vast array of events into a vector representation of the player. So it's one token, one token, so one neural network that transforms for any player their stream event streams to this vector representation.
Thank you. Good.
There's one more question. Very good. Just a second.
Hello, my name is Mislav. I have not a technical question. I have 2 kids. I was teaching them not to use drugs, not to talk to people who can manipulate them, and now I teach them not to play games who can manipulate them using machine learning. What is your take on ethical question? Because if you succeed in machine learning, you actually create an addiction to a specific person to use it indefinitely.
So King, Candy Crush, it's not get quick rewards or maximize revenue in the short term. The business model is player lifetime value, which means that you have to have a sustainable model, which is why there are, even you just ignore machine learning, there are significant limitations on how long you can play, what you can spend, and so on, that are built in, sort of safeguards in it. Obviously, with machine learning, it depends on what you are optimizing for. Right? So if you're just optimizing for maximize gross bookings at any cost, then yes. But that would be a very short-term thing. And there is a segment, I mean, casino games and things like that, who are in that space. King isn't. We're sort of looking at the longer term of, and then there it becomes that you have to, over a long period of time, you have to provide the value to the players that they think that it's worth spending money on.
Thank you.
With that, I was hoping to end this part of the kickoff of the summit and the Digital Product Management Week. I have 2 small presents for you. One is a little bit of a Chalmers water bottle, which I hope you appreciate.
Thank you.
But the second one is actually a little bit more different. The touch point between you and me was actually your father. Ivica, Luca's father, also was the Chalmers representative on the board of Gate AI, which is a research center in Sofia, Bulgaria. And he was very active involved in that before he passed away. I replaced him as the Chalmers representative and board member. But when Gate opened their new building, the main hall of that building is named after your father.
Wow.
And what I have here, sorry, now the microphone stops, is a number of pictures of the hall and the sign where it says the name of your father. So I wanted to give this as a special token.
Wow.
Of the and now we are going to break for lunch. Not lunch. I am hungry, but not that hungry yet. And we are a little bit behind schedule. Let's try to keep it to 20 minutes. So 10:40 we continue in this room. Luca will be here for